Hello everyone, we are now on week 6, topic 3, part 1, and our topic is solving exponential equations and inequalities. And this topic is found on pages 95 to 100 of your module. Okay, but before we continue, I would like you to review first the concept of the loss of exponent. We have discussed this in our previous video. Okay, so we have already discussed the zero exponent and the negative exponent and the identity exponent, the product of powers, the quotient of powers, the power of a power, the power of a product, and the power of a quotient. Okay, so for us to solve for the exponential equations and inequalities, you must have mastered this concept of the loss of exponents. So if you have time, go back and review. Okay, so let us now continue. We have some exponential equations can be solved by using the fact that exponential functions are one-to-one. So what is this one-to-one property of exponential functions? So it says if x sub 1 is not equal to x sub 2, then b raised to x sub 1 is not equal to b raised to x sub 2. Conversely, if b raised to x sub 1 is equal to b raised to x sub 2, then x sub 1 is equal to x sub 2. Okay, so in short, if we have this equation and we have the same bases and they are equal, therefore the exponents are equal. Okay, so if these two expressions are not equal, okay, though they have the same basis, we can say that the exponents are not also equal. Okay, so later you can understand if we have an example of what this one-to-one property of exponential functions means. So let us have an example. Example number 1, solve the equation 4 raised to x minus 1 is equal to 16. So using this concept, our target is to make our bases equal so that we can equate the exponent. So that is what we mean by this one-to-one property of exponential functions. Okay, so we have the base 4, and the other hand we have 16. So how do we make these bases equal? Okay, so the first base is 4 and the other one is 16. So to make these bases equal, we can express 16 as 4 squared. Okay, so we have 4 squared. Now we have already we have the same bases, and since we have the same bases, we can now equate the exponent, the two exponents, and we will be solving for the value of x. So the exponents are x minus 1 is equal to 2, and we will be solving for the value of x, applying the addition property of equality. So we have x is equal to 2 plus 1. Okay, and therefore the value of x is equal to 3. We can also have another solution of this. Okay, we can make our bases equal to 2, so your 4 can be expressed as 2 squared and 16 can be expressed as 2 raised to 4. Okay, and now using the law of exponent, we can multiply these two exponents. So we have 2 times x is 2x and 2 times negative 1 is negative 2. Okay, so now we have the same basis, which is 2. Therefore, applying the one-to-one property of exponential functions, we can equate the two exponents. Okay, so we have 2x minus 2 is equal to 4. And we will be solving for the value of x. So applying the addition property of equality, so you have 4 plus 2 equals 6. And then if we will be dividing both sides of the equation by 2, we can get the value of x. So 2x divided by 2 is x. 6 divided by 2 is 3. So therefore the value of x is 3. So we have the same answers, which is 3. Okay, so let us check our work. The value of x is 3. We will substitute the value of x, or the value of 3 to x. So by substitution, we have 4 raised to 3 minus 1 is equal to 16. And then 3 minus 1 is 2. And 4 squared is equal to 16. So therefore, we have 16 is equal to 16. And we can conclude that for this exponential equation, the value of x is 3. Next, we have example number 2. 125 raised to x minus 1 is equal to 25 raised to x plus 4. Okay, so again, our target is to have the same bases. Okay, so we have our bases are 125 and 25. So how do we make this equation so that we can have the same bases? So our 125 can be expressed as 5 cubed, and your 25 can be expressed as 5 squared. Okay, and then we can apply the laws of exponent. Okay, so we can multiply these two exponents and these two also. Okay, so these are the two exponents. So since we have the same bases, we can now equate the two exponents, and we can distribute, or we can multiply these two by distributing 3. So we have 3 times x is 3x, 3 times negative 1 is negative 3, and then 2 times x is 2x, and 2 times 3 is positive 6. Okay, for this equation, we'll be combining similar terms. So we have 3x, you have minus 2x, and we have 6. We have positive 3 by applying the addition property of equality. And simplify, we have x, or 3x minus 2 is x. 6 plus 3 is 9. So therefore the value of x is 9. So let us check if the value of x is 9. So this is the original exponential equation. Substitute 9 to x. Okay, so we have 125 can be expressed as 5 cubed, and 25 can be expressed as 5 squared. So 9 minus 1 is 8. 9 plus 3 is 12. Okay, and then 3 times 8 is 24. 2 times 12 is 24, and therefore we have 5 raised to 24 is equal to 5 raised to 24, and therefore we can say that for this exponential equation, the value of x is 9. Okay, next we have example number 3. Solve the equation 9 raised to x squared is equal to 3 raised to x plus 3. Okay, so again, our target is to make our bases the same. So we have 9 and 3. Okay, so we can express 9 as 3 squared. Okay, and then applying the law of exponents, we have 2 times x squared is 2x squared, and we have the other exponent is x plus 3. Since we have the same bases, we can equate the two exponents. Okay, and if you can see, we have a quadratic equation because we have a polynomial equation of second degree. And if you can still remember, how do we solve for the values of x for quadratic equation? Okay, so first we will equate all the terms to 0. So we have 2x squared. You have positive x becomes negative x. Your positive 3 becomes negative 3. And these terms are equated to 0. Okay, after equating to 0, what's next? How do we solve for the values of x? Okay, in your mathematics grade 9, you have discussed 3 ways in solving for the values of x for quadratic equations, and these are factoring, completing the square, and using the quadratic formula. So if you have time, please review the topic solving quadratic equations by these 3 methods. Okay, so for this particular example, we will be using factoring. So we will factor this trinomial, quadratic trinomial, and the factors are 2x minus 3 and x plus 1. So if you have time, again, another concept that you need to master is factoring. Okay, so in your spare time, or in your vacant time, you can review on the topic factoring. Okay, so after factoring this side of your equation, we will be equating each factor to 0 and solve for x. Okay, so the first factor is 2x minus 3, and then we will equate this to 0, and the second factor is x plus 1. Still, we will be equating this to 0. And then let us go back to the first equation. We will solve for the value of x. So applying the addition property of equality, we have 2x is equal to 3. We will divide both sides of the equation by 2, and therefore our x is equal to 3 halves. Next, for the second equation, x plus 1 is equal to 0. Applying the addition property of equality, we have x is equal to negative 1. So for this particular exponential equation, we have two values of x, 3 halves and negative 1. So let us check our work. For the values of x, the first value of x is 3 halves. So let us substitute to the value of x. Okay, so 9 raised to 3 halves raised to 2 or squared. And we have 3 raised to 3 halves plus 3. Okay. Okay, so 3 halves squared is equal to, okay, 3 squared is 9, 2 squared is 4. And on the other side of your equation, we are adding 3 and 3 halves. So again, another concept is adding fractions. Okay, adding fractions. So for this one, we'll be finding for the LCD. So for 3 halves and 3, the LCD is 2. So what shall we do with this LCD? We will divide this LCD by the denominator, and the answer of that is to be multiplied to the numerator. So the LCD is 2. 2 divided by 2 is 1. 1 times 3 is 3. Copy the addition sign or the plus sign. And then for 3, we all know that the denominator of 3 is 1. So the LCD is 2 divided by 1 is 2. 2 times 3 is 6. Okay, and we can add 3 and 6. So we have the law of exponent. We will be multiplying these two exponents. So 2 times 9/4 equals, okay, so we have 2 times 9 is 18 over 4. Okay, so simplify 18 over 4, that is 9/10. Okay, on the other side, we have 3 plus 6 is 9. Copy the denominator, and therefore we have 3 raised to 9/2 is equal to 3 raised to 9/2. So therefore, one of the values of x for this exponential equation is 3/2. Now let us check if we have x is equal to 1. Substitute to the value of x. Okay, so we have -2 squared, or -1 squared is +1. -1 plus 3 is 2. So we have 9 raised to 1 is equal to 3 squared, and then we have 3 squared is equal to 9. 9 raised to 1 is 9. So we have 9 is equal to 9, and therefore another value of x is -1. Okay, so we have two values of x, 3/2 and -1. Okay, so now let us proceed to solving exponential inequalities. So, but first, let us first discuss the property of exponential inequalities. If b is greater than 1, then the exponential function y is equal to b raised to x is increasing for all x. This means that b raised to x is less than b raised to y if and only if x is less than y. Next, if b is between 0 and 1, then the exponential function y is equal to b raised to x is decreasing for all x. This means that b raised to x is greater than b raised to y if and only if x is less than y. Okay, so what does it mean? Again, as a review, we have two intervals for the value of b. B can be greater than 0 and b can be between 0 and 1. Okay, so for the property of exponential inequalities, if your b is greater than 0, if you can see, we have less than and less than, while for the second paragraph, if we have greater than, we have less than. So it simply shows that when the value of your b is between 0 and 1, the opening of your sign is reversed. Okay, so take note of the value of b for b is greater than 1 and for b is between 0 and 1. So for you to understand more, let us have an example. Solve the inequality 3 raised to x is less than 9 raised to x minus 2. So for the solution, okay, so still our target is to make our bases equal. So the bases are 3 and 9. Okay, so we can express 9 as 9 squared. Okay, so then applying the law of exponent, we can multiply these two exponents. So we have 3x is less than 3 squared, 3 raised to 2 times x minus 2. we'll be multiplying these two exponents. So it becomes 3 raised to x is less than 3 raised to 2x minus 4. So since we have already the same basis, our concern are for the two exponents. Okay, so we will focus on these two exponents. Okay, so according to this the property of exponential inequalities, we have to consider the value of b, whether it is greater than 1 or between 0 and 1. So in this case, 3, the base is 3, which is greater than 1. So for your exponents, we have x is less than 2x minus 4. So if you can observe, our sign of inequality is not reversed. So this is less than, and for our two exponents, we are using also the less than sign. So it is not reversed because our base is 3, which is greater than 1. Okay, so going back to these two exponents, we will be solving for the value of x. Okay, so applying the property of inequality, which is addition property, we can combine the two terms. So negative 4 becomes positive 4, your positive x becomes negative x. We'll be combining these two terms, similar terms, and so 2x minus x is x, and therefore the value of our x is greater than 4. Okay, so it means to say that if we have this illustration, we have this is 4 and the values of x is greater than 4. So all the values greater than 4 could be the possible values of x. And remember, this is a hollow point, which means to say that 4 is not included as the value of x. So we can have 5 as the value of x, we can have 4.5 as the value of x, but not negative 4, negative 3, because these numbers are less than positive 4. Okay, so we can substitute any values of x to the inequality as long as these values of x are greater than 4. Okay, next, let us proceed to example number 5. So we have solved the inequality 1 over 10 raised to x plus 5 is equal or greater than 1 over 100 raised to 3x. Okay, so solution. Okay, again, our target is to make our bases equal. So for 1 over 100 can be expressed as 1 over 10 squared. Okay, so applying the loss of exponent, we can have okay, so we have 2 as the exponent of 10. So applying the loss of exponent, it becomes 6x. So we will be multiplying 2 and 3x. Okay, so we have 1 over 10 raised to x plus 5 is equal or greater than 1 over 10 raised to 6x. Okay, and we have now the same bases, so therefore our concern now are for these two exponents. And take note that our bases 1 over 10 is between 0 and 1. So therefore, for our two exponents, the sign is reversed. So we have equal or greater than, it becomes equal or less than. Okay? And now we will be solving for the values of x. We'll be combining similar terms using the addition property of equality. So we have 5 and we have 6x. Your positive x becomes negative x, and we will combine similar terms. 6x minus x is equal to 5x, and we will be dividing both sides of the inequality by 5, and therefore your x is greater than or equal to 1. So this is the value of x. If we have our number line, let us visualize the value of x. Okay, so x is greater than or equal to 1. Okay, so this is a point and this is not hollow, it is shaded because 1 is part of the solution set. So 1 is included as the value of x, and all the values of x greater than 1. So you can have values of x as 4, 5, 100, 1000, 2.5, and so on. You can give as many as you can, but you cannot use, or you cannot use 0, -1, and so on as the values of x. Okay, and now let us proceed to our last example, example 6. Okay, we have a problem here. We have the half-life of zinc 71 is 2.45 minutes. Initially, there were y sub 0 grams of zinc 71, but only 1/256 of this amount remains after some time. How much time has passed? Okay, so for the solution, if you can still remember the formula for half-life, y is equal to y sub 0 times 1/2 raised to capital T over T. So if you have time, go back to our previous video about half-life. Okay, so remember that y sub 0 is the initial amount. Okay, so the capital T is the half-life of the given substance, and T is the time that has elapsed. Okay, and since we are talking about half-life, this is 1/2. So using the formula, we'll be substituting the values. Okay, so we don't know the initial amount, and then we have half-life, and the half-life of zinc 71 is 2.45 minutes. Okay, so again, we don't know the initial amount, and you are asked to solve for the time, how much time has passed. Okay, so again, you are asked to solve for the value of t, small letter t, and we all know that after t, the remaining amount is 1/256 of the initial amount. Okay, so again, we don't know the initial amount, but after the time has passed, what is left is 1/256 of the initial amount, and this one is the value of our y. Okay, from the formula, this 1/256 of y sub 0 is the value of our y, and therefore our y is 1/256 of that initial amount. Okay, so using this equation, we can substitute this expression to our formula y. Okay, so y, and this is also the value of y. Okay, so by substitution, this is your y from this equation y. Okay, we have substituted this from this equation. Okay, and then we will copy this exponential expression. Okay, and our target is to solve for the value of t, okay, which is the time that has elapsed. So from this equation, we have y sub 0, applying the properties of equation. We can divide both sides of the equation by y sub 0 so that we can eliminate the y sub 0. So therefore, eliminating y sub 0, this is our exponential equation. Okay, so we have already eliminated y sub 0. So from this, we will be solving for the value of t. Okay, so again, we will be using the concept of making our bases equal. So the bases are 1 over 256 and 1/2. So how do we make this having the same bases? Okay, so 1 over 256 can be expressed as 1/2 raised to 8. Okay, so 1 raised to 8 is 1, 2 raised to 8 is 256. Okay, now we have already the same bases, which is 1/2, and therefore we can now equate the two exponents. Okay, so we have 8 is equal to t over 245 or 2.5. Or I'm sorry, this must be 256. Okay, so take note of the correction. This must be 256. Okay, 256 and not 245. Okay, so multiplying both sides of the equation by 256, the value of t is 19.6, and the unit of time is minutes. Okay, so therefore the value of t is 19.6 minutes. Okay, so that is one of the applications of solving exponential equations and inequalities. Okay, so for this video, we have discussed solving exponential equations, and take note that in our given examples, you must able to determine, or you will be using the loss of exponent so that our bases will become or will be the same, and work on the exponents of the exponential equations. Okay, so that's all for this video, and I hope you have learned something from our discussion. So thank you very much, and good luck for the next topic.